The world of agriculture is undergoing a profound transformation. Are we on the verge of a new green revolution? With global food demands increasing, how can technology revolutionize the way we produce food while safeguarding the planet? The answer lies in cutting-edge innovations that are reshaping agriculture as we know it. Join us as we explore 7 groundbreaking technologies that are powering the next wave of the green revolution. Together, let's dive into how these advances are leading us toward a more sustainable future. Stay tuned. This is a journey you won't want to miss. Precision farming, data-driven agriculture. Precision farming has transformed traditional agriculture by integrating advanced technology to optimize crop production and reduce environmental impact. This modern approach utilizes tools like GPS, drones, and sensors to gather real-time data on soil conditions, weather, and crop health. By analyzing this data, farmers can make precise decisions on planting, irrigation, and fertilization, ensuring that each area of the field receives the appropriate treatment. This results in higher yields, better resource management, and a reduced ecological footprint. A key advantage of precision farming is its ability to minimize water and chemical waste. Through the use of moisture sensors and automated irrigation systems, plants receive the exact amount of water they need, preventing both over- and underwatering. This method conserves water and reduces runoff from excessive irrigation. Additionally, variable rate technology, or VRT, enables precise application of fertilizers and pesticides, applying only the required amount based on crop needs. This minimizes environmental pollution and lowers costs for farmers. Drones and satellite imaging play a crucial role in precision farming, allowing farmers to monitor large areas of land efficiently. These tools capture high-resolution images that help detect issues like pest infestations, nutrient deficiencies, and water stress. With this detailed insight, farmers can address problems early, making interventions more timely and effective. The use of drones reduces the need for manual inspections, saving time and labor while improving overall farm management. As global food demand rises and climate change challenges agriculture, precision farming offers a vital solution. By leveraging data and technology, farmers can produce more food with fewer resources, supporting food security and environmental sustainability. As these technologies become more accessible, precision farming is poised to become a foundational practice in modern agriculture, meeting the demands of a growing population while preserving the planet's ecological balance. Vertical farming revolutionizing urban agriculture. Vertical farming is transforming food production by using vertically stacked layers to grow crops in controlled environments. This method allows year-round cultivation, often in urban areas where space is limited and traditional farming is impractical. With artificial lighting, climate control, and hydroponic or aeroponic systems, vertical farming offers a sustainable solution to the growing challenge of feeding a rising urban population without being affected by seasonal or weather conditions. One of the major benefits of vertical farming is its resource efficiency. Compared to traditional agriculture, vertical farming uses up to 95% less water by recycling it in a closed-loop system, which minimizes waste. Additionally, since these farms are often located near urban centers, the need for long-distance transportation is significantly reduced. This not only cuts fuel consumption and carbon emissions, but also ensures fresher, nutrient-rich food reaches consumers faster, improving both quality and shelf life. Vertical farming is also well suited for areas that lack suitable land for traditional farming. Cities like Singapore and New York, where space is scarce, have adopted vertical farming to boost food production. These farms can be set up in unused warehouses, shipping containers, or even skyscrapers, maximizing space in crowded areas. By growing food locally, vertical farming reduces dependence on global supply chains, making it more resilient to disruptions caused by extreme weather, trade issues, or pandemics. Beyond food security, vertical farming addresses key environmental concerns. Traditional farming is often linked to deforestation, soil degradation, and biodiversity loss. In contrast, vertical farming requires no arable land, reducing pressure on ecosystems. It also minimizes the use of pesticides and herbicides, cutting chemical runoff into water bodies. As vertical farming technology advances, it holds the potential to reshape global agriculture, creating a more sustainable, resilient food system for future generations. Gene editing, a new era of crop improvement. Gene editing, especially through CRISPR technology, is transforming agriculture by enabling the rapid development of more resilient, nutritious, and sustainable crops. Unlike traditional breeding, which can take years to achieve desired traits, gene editing allows scientists to make precise changes in plant DNA much faster. This innovation is creating crops that can better withstand environmental stresses such as drought, pests, and diseases, while also boosting yields and nutritional value. As global population grows and climate challenges intensify, gene editing holds great promise for improving food security. One critical application of gene editing is developing crops that can thrive in tough environmental conditions. For example, CRISPR is being used to produce drought-resistant varieties of corn and rice, which can grow in regions affected by climate change. Gene editing also enhances heat and salt tolerance in crops, making it possible to farm in areas previously unsuitable for agriculture. These developments are essential for regions with water scarcity or poor soil, where traditional crops struggle to survive. Beyond environmental resilience, gene editing is improving the nutritional content of food. Scientists have developed crops like iron-enriched rice and vitamin A-fortified cassava, which address nutrient deficiencies in many developing countries. These bio-fortified crops could help reduce malnutrition and reliance on supplements in areas where key nutrients are scarce. By making staple foods healthier, gene editing has the potential to improve global nutrition and public health. However, gene editing faces challenges such as regulatory hurdles and public concerns about genetically modified organisms, or GMOs. While gene-edited crops differ from GMOs as they don't involve foreign genes, public perception remains a barrier. Scientists and policymakers need to create clear regulations and educate the public on the safety and benefits of gene-edited crops. As these issues are resolved, gene editing is likely to become a central tool in modern agriculture, helping to sustainably increase food production and enhance nutrition worldwide. Robotics in farming, automating agriculture. The rise of robotics in farming is transforming agriculture by automating labor-intensive tasks and boosting efficiency. From autonomous tractors to fruit-picking robots, these technologies are revolutionizing how crops are grown, managed, and harvested. As agriculture faces challenges like labor shortages, rising food demand, and environmental pressures, robotics offers solutions that improve productivity and resource conservation. These innovations are paving the way for a future where machines work alongside farmers, elevating efficiency. A key application is autonomous machinery. Self-driving tractors equipped with GPS and AI can plow, plant, and harvest with minimal human input. These machines work 24/7, executing tasks with precision and speed beyond human capability. Autonomous robots also handle repetitive tasks like weeding and seeding, reducing labor needs and increasing accuracy. This precision helps farmers cut costs, optimize resources, and minimize environmental impact. Robotics is also changing how crops are harvested, especially delicate fruits. Traditionally, fruit picking required large labor forces, but robots with advanced vision systems can detect and pick fruits like strawberries and apples at peak ripeness, reducing waste and speeding up harvests. Beyond the fields, robotics is enhancing processes like sorting, packaging, and livestock management. Robotic milking systems allow cows to be milked on demand, improving efficiency and animal welfare. Robots can also monitor livestock health, detecting early signs of illness. As these technologies evolve, they help farmers adopt more sustainable, humane practices, contributing to a greener future for agriculture. Green ammonia revolutionizing fertilizer production. Ammonia is vital for fertilizers, supporting nearly half of the world's food production by enhancing crop yields. However, traditional ammonia production via the Haber-Bosch process is energy-intensive, consuming around 2% of global energy and contributing approximately 1.8% of CO2 emissions. The rise of green ammonia, produced using renewable energy, offers a more sustainable and eco-friendly alternative. This innovation not only lowers greenhouse gas emissions, but also addresses the growing food demand more responsibly. Green ammonia is made by combining nitrogen from the air with hydrogen produced through electrolysis powered by renewable sources like wind and solar. Unlike traditional fossil fuel-based methods, green ammonia generates zero carbon emissions. This is a crucial development in decarbonizing agriculture, as fertilizers are key to global food production. By transitioning to green ammonia, the agricultural sector can significantly reduce its carbon footprint, supporting global climate goals. In addition to its use in fertilizers, green ammonia holds promise as a clean energy source. It can be stored and transported more easily than hydrogen and used as fuel, particularly in industries like shipping that are seeking alternatives to carbon-heavy fuels. Ammonia-powered ships could reduce emissions in the maritime industry, contributing to broader efforts to decarbonize global industries. Its dual role as a fertilizer and clean fuel makes green ammonia a critical tool in the shift toward a low-carbon economy. Countries and companies are investing in green ammonia with pilot projects in Australia, Europe, and Japan. As renewable energy becomes more accessible and cost-efficient, green ammonia production is expected to scale up, making it a viable alternative to traditional ammonia. This marks a major step toward agricultural sustainability and a cleaner energy future, where food production and energy consumption are more environmentally friendly. Connected technology, the Internet of Things, IoT, in agriculture. The Internet of Things, IoT, is revolutionizing agriculture by connecting devices, sensors, and machinery to create smart farming ecosystems. By collecting real-time data and analyzing it on cloud platforms, IoT allows farmers to monitor, automate, and optimize their operations more effectively. From soil sensors to drones, these technologies enable data-driven decisions, improving productivity and reducing resource waste. As IoT continues to integrate into farming, it is reshaping agriculture for a more efficient future. A key benefit of IoT in agriculture is precision irrigation management. Soil sensors measure moisture, temperature, and nutrients, providing farmers with real-time data on soil conditions. This enables accurate water management, ensuring crops get the right hydration. Automated irrigation systems can activate only when necessary, conserving water and reducing costs, especially crucial in drought-prone regions. IoT also enhances pest control and crop health monitoring. Drones equipped with cameras and sensors can survey large areas, detecting early signs of disease, pests, or nutrient deficiencies. This allows farmers to address issues promptly, applying fertilizers or pesticides only where needed, minimizing chemical use and reducing environmental impact. Smart pest monitoring systems also enable targeted interventions, improving sustainability. As 5G networks expand, IoT will become even more advanced, allowing seamless communication between devices and deeper data analysis. Farmers will be able to remotely control key aspects of their farms via smartphone apps, from irrigation to livestock monitoring. Predictive analytics powered by machine learning will help farmers forecast crop yields, optimize planting schedules, and anticipate challenges like extreme weather. With IoT, agriculture is becoming smarter, more sustainable, and better equipped to feed a growing global population. AI and robotics, shaping the future of agriculture. Artificial intelligence, AI, and robotics are revolutionizing agriculture, transforming how crops are grown, managed, and harvested. These technologies address key challenges like labor shortages and the need for higher food production amidst climate change. By integrating AI-driven data analysis and autonomous robots, farming is becoming more efficient, precise, and sustainable. These innovations are laying the groundwork for the future of agriculture, where technology plays a crucial role in feeding the world's growing population. AI's greatest impact in agriculture is its ability to optimize farming decisions. AI-powered systems analyze data such as soil conditions, weather patterns, and market trends, helping farmers make smarter choices about planting, watering, and harvesting. Machine learning algorithms can also predict pest outbreaks and diseases, enabling proactive measures that reduce pesticide use and protect crops. Through predictive analytics, AI increases crop yields while minimizing waste and conserving resources. Robotics automates many time-consuming tasks. Autonomous tractors can plow fields with accuracy, while robotic harvesters pick delicate fruits and vegetables without damage. These machines work faster and more efficiently than human labor, reducing the need for large workforces. Robots are also being developed for tasks like weeding, seeding, and milking cows, allowing farmers to save time, cut costs, and improve productivity while ensuring consistent quality. In plant breeding and greenhouse management, AI models accelerate the development of climate-resilient crops by identifying desirable genetic traits. AI-driven greenhouse systems automatically regulate temperature, humidity, and lighting to create optimal growing conditions. These advancements promote sustainability by reducing water, energy, and chemical use. As AI and robotics evolve, they are set to reshape agriculture, making it more productive and sustainable for the future. As we wrap up, it's clear that the future of agriculture lies in the innovative technologies driving the green revolution. From precision farming to AI and robotics, these advancements are reshaping how we grow food sustainably in a rapidly changing world. If you enjoyed this exploration, be sure to like, share, and subscribe to InnoVision Tech. Don't forget to hit the bell icon to stay updated with our latest videos. Until next time, keep discovering the world's wonders with us. Have you ever wondered what lies beyond the point of no return, where even light cannot escape? Black holes, the enigmatic monsters of the cosmos, have fascinated scientists and dreamers alike for decades. From their mysterious formation to their immense gravitational power, black holes challenge our understanding of space and time. Join us as we dive into the incredible world of black holes and uncover their secrets, exploring the science, the wonder, and the unknown. The formation of black holes, the birth of a cosmic giant. Black holes form from the remnants of massive stars that have reached the end of their lives. As a star burns through its nuclear fuel, it maintains a delicate balance between the outward pressure of nuclear fusion and the inward pull of gravity. When the fuel is depleted, gravity wins the battle, causing the star to collapse under its own weight. For stars much larger than our Sun, this collapse leads to the formation of a singularity, a point of infinite density where the laws of physics as we know them break down. Surrounding this singularity is the event horizon, the boundary beyond which nothing can escape. The gravitational pull here is so intense that not even light, the fastest thing in the universe, can escape its grasp. Not all black holes are created equal. Stellar mass black holes are born from the death of stars, while supermassive black holes, millions to billions of times the mass of our Sun, reside at the centers of galaxies. These colossal entities likely formed from the merger of smaller black holes and the accretion of vast amounts of matter over time. Intermediate mass black holes, a middle ground between stellar mass and supermassive, have been harder to find, but their discovery has opened new avenues for understanding black hole evolution. Their formation remains one of the great mysteries in astrophysics, providing a link between the small and the colossal. The creation of black holes is a process that illustrates the immense power and complexity of the universe. From the remnants of dying stars to the titanic forces shaping galaxies, black holes remind us that even destruction can lead to profound new beginnings in the cosmos. The anatomy of a black hole, beyond the event horizon. A black hole is more than just an abyss. It is a complex structure with distinct parts that play a crucial role in its behavior and influence. At its heart lies the singularity, the point of infinite density and zero volume where gravity is so intense that it warps space and time to extremes. Surrounding the singularity is the event horizon, often referred to as the point of no return. Once an object crosses this boundary, escape becomes impossible. The event horizon is not a physical surface, but rather a mathematical boundary defined by the black hole's immense gravitational pull. Outside the event horizon, many black holes are surrounded by an accretion disk, a swirling mass of gas, dust, and debris drawn in by the black hole's gravity. As this matter spirals inward, it heats up to millions of degrees, emitting intense radiation that can be detected by telescopes on Earth. In some cases, black holes produce powerful jets of high-energy particles that shoot out from their poles at nearly the speed of light. These jets are powered by the intense magnetic fields generated by the accretion disk and can extend for thousands of light years, influencing the formation of stars and galaxies. Understanding the anatomy of a black hole reveals the intricate processes at work in these celestial phenomena. They are not simply voids, but dynamic and influential objects that play a pivotal role in shaping the universe around them. How black holes warp space and time. Black holes are more than gravitational traps. They are cosmic engines that distort the fabric of space and time. According to Einstein's general theory of relativity, massive objects like black holes curve space-time, much like a heavy ball placed on a stretched rubber sheet. As a result, time near a black hole slows down relative to an observer far away. This phenomenon, known as time dilation, means that a clock near the event horizon ticks more slowly than one in a distant region of space. If you were to observe an astronaut falling into a black hole, Their movements would appear to slow down as they approached the event horizon, eventually freezing in place. The intense warping of space-time also affects light. Black holes can bend light paths, creating a phenomenon called gravitational lensing. This effect allows astronomers to see objects hidden behind massive celestial bodies, as light from distant stars and galaxies is bent around the black hole. At the event horizon, space-time becomes so warped that all paths lead inward. Once something crosses this boundary, it is destined to fall into the singularity. This extreme distortion of space-time challenges our understanding of the universe and raises questions about the nature of reality itself. By studying how black holes warp space and time, scientists gain insights into the fundamental laws of physics and the relationship between gravity, matter, and energy. Black holes are laboratories for testing the limits of our theories and exploring the universe's deepest mysteries. Black holes and the cosmic web. Black holes are not isolated entities. They are deeply connected to the large-scale structure of the universe. They play a central role in the formation and evolution of galaxies, often acting as the anchors around which galaxies grow. Supermassive black holes, located at the centers of galaxies, influence the motion of stars and gas in their vicinity. Their immense gravitational pull binds galaxies together, while the energy released from accretion disks and jets can regulate star formation by heating and dispersing surrounding gas. Galactic collisions and mergers often lead to the merging of black holes, creating even larger supermassive black holes. These events release powerful gravitational waves, ripples in space-time that can be detected by instruments like LIGO and Virgo. The relationship between black holes and the cosmic web extends beyond galaxies. The jets from supermassive black holes can shape the intergalactic medium, distributing energy and influencing the formation of galaxy clusters. Black holes are key players in the intricate interplay of forces that define the universe's structure. By understanding the connection between black holes and the cosmic web, astronomers piece together the story of how galaxies and the universe itself have evolved over billions of years. The Event Horizon Telescope. The Event Horizon Telescope, or EHT, represents a groundbreaking effort to capture images of black holes, allowing humanity to glimpse the unseeable. Using a global network of radio telescopes synchronized to act as a single Earth-sized instrument, the EHT captured the first-ever image of a black hole in 2019. This historic achievement revealed the shadow of the black hole at the center of galaxy M87, surrounded by a glowing ring of hot, spiraling matter. The image was more than just a visual spectacle. It confirmed the existence of event horizons and matched predictions made by Einstein's theory of general relativity. The glowing ring represents light bending around the black hole, while the dark shadow marks the region where light cannot escape. This discovery offered direct evidence of how black holes warp spacetime and manipulate matter. The EHT's success was a culmination of years of collaboration among hundreds of scientists and engineers. Data collected from observatories worldwide was combined using a technique called very long baseline interferometry, enabling the extraordinary resolution necessary to image a black hole's shadow. Building on this achievement, the EHT is now targeting other black holes, including the one at the center of our galaxy, Sagittarius A*. These efforts promise to reveal even more about the enigmatic nature of black holes and their environments, providing a window into phenomena that were once purely theoretical. The Event Horizon Telescope has opened a new frontier in astronomy, proving that humanity can tackle the most daunting challenges in exploring the cosmos. It is a testament to the power of global collaboration and the unyielding human desire to uncover the universe's deepest mysteries. The power of gravitational waves. Listening to cosmic collisions. Gravitational waves, ripples in the fabric of spacetime, are one of the most exciting tools for studying black holes. First predicted by Einstein's general theory of relativity, these waves are produced by cataclysmic events such as the collision of black holes. In 2015, the LIGO Observatory detected gravitational waves for the first time, marking a new era in astrophysics. When two black holes spiral toward each other and merge, they release an immense amount of energy in the form of gravitational waves. These ripples travel across the universe, carrying information about the masses, spins, and distances of the merging black holes. Observatories like LIGO and Virgo capture these signals, allowing scientists to study cosmic events that would otherwise be invisible. Gravitational wave astronomy has led to several remarkable discoveries. It has revealed the existence of binary black holes, confirmed theories about their formation, and provided insights into the nature of space-time itself. Each detection expands our understanding of the violent and dynamic processes that shape the universe. The study of gravitational waves has also opened the door to exploring the unknown. By observing waves from black hole collisions, scientists test the limits of general relativity and search for evidence of phenomena like primordial black holes, which may have formed shortly after the Big Bang. Gravitational waves are more than a breakthrough. They are a new way of experiencing the universe. They allow us to listen to the cosmos, unlocking secrets that were once hidden in silence and enriching our understanding of black holes and their dramatic lives. Black holes and the nature of information. Black holes present one of the most perplexing paradoxes in modern physics, the information paradox. According to quantum mechanics, information about the physical state of matter should never be destroyed. However, when matter falls into a black hole, it appears to vanish beyond the event horizon, seemingly erasing all traces of its properties. This paradox challenges the foundations of physics. Stephen Hawking's groundbreaking work on black hole radiation, known as Hawking radiation, suggests that black holes emit energy and can eventually evaporate over immense timescales. Yet this radiation seems to carry no information about the matter that formed the black hole, intensifying the puzzle. Physicists have proposed various solutions to the paradox. One theory suggests that information is encoded on the event horizon itself, much like a hologram. This concept, known as the holographic principle, implies that the universe's three-dimensional nature may be a projection of information stored on a two-dimensional surface. Another idea is that information may escape through subtle quantum effects during the emission of Hawking radiation. These theories are still being tested and debated, but they represent profound implications for our understanding of quantum mechanics, gravity, and the nature of reality. The information paradox demonstrates that black holes are not just astronomical objects, but philosophical and scientific challenges. They force us to reconsider fundamental assumptions about the universe, bridging the worlds of quantum mechanics and general relativity in a quest for a unified theory of physics. The ultimate fate of black holes. Black holes are not eternal. Over incredibly long timescales, they lose energy through a process known as Hawking radiation. This phenomenon occurs because of quantum effects near the event horizon, where particle-antiparticle pairs form and one falls into the black hole while the other escapes, carrying away energy. As black holes emit radiation, they slowly lose mass, shrinking over billions or even trillions of years. Eventually, a black hole will evaporate entirely, releasing a final burst of energy before disappearing. This process, though theoretical, has profound implications for the fate of black holes in the universe. In a far distant future known as the heat death of the universe, when stars have burned out and galaxies have dispersed, black holes may be the last remaining objects. Their slow evaporation will mark the final stages of cosmic evolution, leaving a cold, empty expanse. The study of black hole evaporation also sheds light on the interplay between quantum mechanics and gravity. Understanding Hawking radiation could lead to new breakthroughs in unifying these two fundamental forces, offering a glimpse into the underlying fabric of the universe. Black holes, born from the fiery deaths of stars, ultimately fade into obscurity. Their life cycle, from colossal gravitational monsters to evaporating whispers, symbolizes the incredible transformations that define the universe's story. They remind us that even the most powerful phenomena are not immune to the passage of time. The mysteries of black holes inspire awe and curiosity, challenging us to expand our understanding of the universe. From their formation to their profound influence on space and time, black holes are among the most fascinating phenomena in existence. If you enjoyed this exploration, be sure to like, share, and subscribe to InnoVision Tech. Don't forget to hit the bell icon to stay updated with our latest videos. Until next time, keep uncovering the universe's secrets with us.
Did you know that most of the universe is invisible? Scientists believe an elusive force called dark matter shapes galaxies and influences the cosmos in ways we're only beginning to uncover. But what is it, and how do we know it's out there? From its strange properties to the mysteries it holds, dark matter continues to challenge our understanding of reality. Join us as we explore 10 fascinating things you need to know about dark matter, diving deep into the secrets of the unseen universe. Dark matter and the universe's composition. The universe is more mysterious than we ever imagined. While the stars, planets, and galaxies we see fill our night skies, they make up only about 5% of everything in existence. The rest is composed of dark matter and dark energy, which together account for an astonishing 95%. Dark matter alone constitutes roughly 27% of this cosmic makeup. This unseen substance doesn't emit light or energy, making it completely invisible to the naked eye and even to our most advanced telescopes. Despite its elusiveness, dark matter's presence is undeniable. It exerts a gravitational pull on visible matter, preventing galaxies from tearing apart as they spin. Observations of galaxy clusters and gravitational lensing, the bending of light caused by massive objects, offer compelling evidence of its existence. It's the silent architect of cosmic structure, influencing the formation and behavior of galaxies. Dark matter's discovery has been a game-changer in physics and astronomy. Fritz Zwicky first proposed its existence in the 1930s when he observed discrepancies in the Coma cluster's mass. Years later, Vera Rubin's work on galactic rotation curves provided further proof, showing that visible stars alone couldn't account for the gravitational forces at play. This discovery has sparked countless questions. If we can't see it or touch it, what is dark matter made of? Scientists are exploring exotic particles like WIMPs and axions as potential candidates. These investigations are driving groundbreaking research and reshaping our understanding of the universe's fundamental nature. Evidence from galactic rotation. Galaxies are cosmic wonders, but their movement poses a puzzle that only dark matter seems to solve. When astronomers study the rotation of galaxies, they find that the outer stars move just as fast as the inner ones, defying the laws of physics as we understand them. Without a massive amount of unseen matter, these galaxies should have flung themselves apart long ago. Vera Rubin's groundbreaking work in the 1970s provided key insights. She observed that the speed of stars in spiral galaxies didn't decrease with distance from the center, as predicted by Newtonian physics. Instead, the stars on the outskirts moved at nearly the same speed as those near the core. This phenomenon, called the flat rotation curve, pointed directly to the presence of a hidden mass surrounding galaxies. Scientists believe this mass forms a halo of dark matter, enveloping galaxies and holding them together through gravity. Without this invisible structure, the universe as we know it wouldn't exist. Dark matter not only stabilizes galaxies but also plays a critical role in their formation, influencing how stars and clusters come together over billions of years. The evidence for dark matter continues to grow through detailed observations and computer simulations. These models reveal how galaxies evolve, highlighting the essential role dark matter plays in shaping their structure. While the mystery remains unsolved, each discovery brings us closer to understanding this enigmatic force. The bullet cluster and direct proof. One of the most compelling pieces of evidence for dark matter comes from the bullet cluster, a collision of two galaxy clusters that occurred over hundreds of millions of years. This cosmic event has provided astronomers with a rare opportunity to observe the effects of dark matter in action. In this cluster, the visible matter, mostly hot gas, was separated from the dark matter during the collision. Using X-ray observations and gravitational lensing techniques, scientists were able to map the distribution of both. Remarkably, the lensing showed that most of the mass was concentrated in regions where no visible matter was present, aligning instead with the invisible dark matter. The bullet cluster serves as a cosmic laboratory, offering direct proof that dark matter exists and behaves differently from normal matter. Unlike gas and stars, which interact and slow down during collisions, dark matter passes through unimpeded, revealing its unique properties. This discovery has had profound implications for our understanding of the universe. It not only confirms dark matter's existence, but also challenges alternative theories that attempt to explain cosmic phenomena without it. The bullet cluster stands as a striking example of the unseen forces shaping our cosmos. Candidates for dark matter particles. Dark matter remains one of science's greatest mysteries, and uncovering its true nature is a top priority for physicists. Researchers have proposed various candidates for the particles that could make up dark matter, each offering unique possibilities and challenges. One leading contender is the WIMP, or weakly interacting massive particle. These theoretical particles interact only through gravity and the weak nuclear force, making them incredibly difficult to detect. Experiments around the world are searching for these elusive particles, using advanced detectors in underground labs designed to shield against background noise. Another intriguing possibility is the axion, a particle so light and weakly interacting that it's often compared to a ghost. Axions could solve several puzzles in particle physics, including the strong CP problem, while also accounting for dark matter. Innovative experiments are underway to detect these particles using specialized magnetic fields and radio waves. Some scientists are also exploring the idea of sterile neutrinos, a hypothetical type of neutrino that doesn't interact with normal matter. If proven to exist, sterile neutrinos could help explain dark matter's properties and its role in cosmic evolution. While no dark matter particle has been definitively detected, the search is pushing the boundaries of science and technology. Each experiment, whether successful or not, adds to our understanding and brings us closer to unveiling the true nature of the universe. Dark matter and gravitational lensing. One of the most fascinating ways we've detected dark matter is through the phenomenon of gravitational lensing. This effect occurs when massive objects like galaxy clusters bend the light from distant galaxies, acting like a cosmic magnifying glass. Gravitational lensing doesn't just help us see far-off galaxies, it also reveals the presence of hidden mass, dark matter. When astronomers observe lensing, they can calculate the mass of the lensing object based on how much the light bends. Often, the visible matter like stars and gas accounts for only a fraction of the mass required to produce the observed lensing. The rest is attributed to dark matter. This technique has allowed scientists to create detailed maps of dark matter distribution across the universe. What's truly incredible is how gravitational lensing provides a window into the past. The light we see has traveled billions of years, giving us a glimpse of the universe as it was when that light first began its journey. Through this lens we can trace the role of dark matter in forming galaxies and clusters over cosmic history. Gravitational lensing isn't just a tool for studying dark matter, it's also a reminder of the interconnectedness of the cosmos. The unseen mass that warps space and time continues to shape the universe, guiding the paths of light and the evolution of celestial structures. The role of dark matter in cosmic structure formation. The universe we see today, filled with galaxies, stars, and planets, wouldn't exist without dark matter. This invisible substance played a crucial role in the formation of cosmic structures after the Big Bang. In the early universe, tiny fluctuations in the density of matter created gravitational wells, and dark matter provided the necessary scaffolding for these structures to grow. Dark matter clumped together under its own gravity, forming vast cosmic webs that span the universe. These webs became the framework for galaxies and clusters to form, as visible matter was pulled into the dense regions created by dark matter. Without this invisible scaffolding, the universe would be a much emptier place. Simulations of the universe's evolution confirm dark matter's central role. When scientists run models with only visible matter, the results don't match the universe we observe today. But when dark matter is included, the simulations align perfectly, reproducing the large-scale structures we see in the cosmos. Understanding dark matter's role in cosmic structure formation not only explains the past but also helps us predict the future. As we map the universe and uncover more about its hidden components, we deepen our appreciation for the forces that have shaped everything we know. Dark matter and its interaction with normal matter. One of the most perplexing aspects of dark matter is how little it interacts with normal matter. While it exerts a gravitational influence, it doesn't emit, absorb, or reflect light, making it invisible and incredibly hard to detect. Scientists believe this non-interaction is key to its stability and longevity in the universe. Unlike normal matter, which interacts through electromagnetic weak and strong nuclear forces, dark matter seems to avoid all these interactions except gravity. This explains why dark matter doesn't clump together to form stars or planets like visible matter does. Instead, it remains distributed in massive halos around galaxies, influencing their rotation and structure. Despite its elusive nature, researchers are using ingenious methods to detect dark matter's subtle interactions. Detectors placed deep underground are searching for faint signals of dark matter particles colliding with atomic nuclei. While results so far have been inconclusive, each experiment refines our understanding and brings us closer to a breakthrough. The lack of direct interaction with normal matter is both a challenge and a clue. It suggests that dark matter could be composed of entirely new particles or forces, expanding the boundaries of physics and opening doors to unexplored realms of science. Theories and models of dark matters. Dark matter has inspired a wide range of theories, each attempting to explain its nature and origins. One of the most popular models involves WIMPs, or weakly interacting massive particles, which could be remnants from the early universe. These particles are predicted by extensions of the standard model of particle physics, such as supersymmetry. Another intriguing theory involves axions, hypothetical particles that could solve long-standing puzzles in quantum physics. Unlike WIMPs, axions are incredibly light and interact even less with normal matter, making them even harder to detect. Despite these challenges, experiments like ADMX are hunting for evidence of their existence. Some researchers propose that dark matter could be composed of primordial black holes, tiny black holes formed shortly after the Big Bang. These objects could mimic the effects of dark matter, though evidence for this theory remains scarce. Other models suggest exotic forms of matter such as sterile neutrinos or even entirely new dimensions of spacetime. Each theory pushes the boundaries of what we know, driving innovation in both science and technology. The search for dark matter isn't just about solving one mystery, it's about uncovering new laws of physics and redefining our understanding of the universe itself. Dark matter and dark energy, the cosmic connection. While dark matter makes up 27% of the universe, its mysterious counterpart, dark energy, constitutes a staggering 68%. Together, they dominate the cosmos, shaping its fate and evolution. Dark matter and dark energy are distinct yet interconnected forces that define the universe's large-scale behavior. Dark matter provides the gravitational pull needed to form galaxies and clusters, while dark energy exerts a repulsive force, driving the universe's accelerated expansion. This interplay creates a delicate balance, influencing the cosmos on both local and cosmic scales. Without dark matter's gravitational effects, dark energy might have torn apart galaxies long ago. Understanding the relationship between these two phenomena is one of the greatest challenges in modern physics. Observations from missions like the Wilkinson Microwave Anisotropy Probe and the Planck satellite have revealed how dark matter and dark energy shaped the early universe. But many questions remain unanswered. This cosmic connection reminds us of the universe's complexity and the limits of our knowledge. By unraveling the mysteries of dark matter and dark energy, we move closer to answering fundamental questions about the origins and ultimate fate of the cosmos. Future missions and the search for answers. The quest to understand dark matter continues to drive some of the most ambitious scientific missions. From deep space telescopes to underground detectors, researchers are exploring every avenue to uncover its secrets. Upcoming projects promise to revolutionize our understanding of this enigmatic force. The Vera C. Rubin Observatory, set to begin operations soon, will map the night sky in unprecedented detail, tracking the distribution of dark matter across billions of light-years. Meanwhile, experiments like Lux Zeppelin and Xenont are using cutting-edge technology to search for interactions between dark matter particles and normal matter. Space-based missions like the European Space Agency's Euclid telescope aim to study the effects of dark matter on cosmic structures, providing critical data about its distribution and behavior. These efforts, combined with advancements in particle physics, are bringing us closer than ever to solving the dark matter puzzle. The future of dark matter research is filled with promise and possibility. Each discovery adds a new piece to the puzzle, bringing us closer to understanding the invisible forces that shape our universe. The journey is far from over, and the best may still be yet to come. That concludes our journey into the mysteries of dark matter, an unseen force that holds the universe together and challenges our understanding of reality. From its role in shaping galaxies to the ongoing search for its true nature, dark matter is a testament to the wonders of science and discovery. If you enjoyed this exploration, be sure to like, share, and subscribe to InnoVision Tech. Don't forget to hit the bell icon to stay updated with our latest videos. Until next time, keep exploring the universe's greatest mysteries with us. What if I told you space isn't just a vast, beautiful expanse of stars and galaxies, but a terrifying, merciless void filled with things that could wipe us out in an instant? Rogue black holes, deadly gamma-ray bursts, and invisible forces shaping the universe. Space is far scarier than any horror movie. And the best part? We're completely powerless against it. Today, we're diving into the 8 most terrifying things lurking in space, and trust me, you'll never look at the night sky the same way again. Ready to explore the dark side of the universe? Let's begin. Rogue black holes. Alright, imagine this. A monstrous black hole, completely unhinged, drifting through space with no warning, no set path, and nothing stopping it. Unlike the ones chilling at the center of galaxies, rogue black holes are cosmic wanderers, silent, invisible, and devastating. Scientists believe there are millions of these roaming through our galaxy alone. That's right, millions. Now here's the terrifying part. These things don't just sit there, they move. If one were ever to pass close to our solar system, its immense gravity could rip planets out of orbit, or even send Earth spiraling into deep space. And the worst part? We wouldn't see it coming. Black holes don't emit light, making them nearly impossible to detect until they start warping the space around them. The only reason we know rogue black holes exist is because scientists have observed stars behaving strangely, suddenly speeding up or bending their trajectory as if an invisible force was yanking them. That's a telltale sign that something dark, something unseen, is lurking nearby. So, what's stopping a rogue black hole from one day wandering too close to Earth? Nothing. And that's what makes them so terrifying. Gamma-ray bursts. Imagine waking up one morning, stepping outside, and boom, the sky lights up with an intense flash of energy. No warning, no escape, just a blinding burst of cosmic radiation that wipes out everything in its path. That's a gamma-ray burst, GRB, one of the most powerful and terrifying events in the universe. GRBs are like space's deadliest sniper shots, fired from collapsing stars or merging neutron stars. These bursts release more energy in a few seconds than our sun will in its entire lifetime. If a gamma-ray burst ever hit Earth head-on, it wouldn't just scorch the surface. It could strip away our atmosphere, exposing us to lethal radiation and making life impossible. And here's the truly scary part. We wouldn't even see it coming. These bursts travel at the speed of light, meaning by the time we detected one heading our way, it would have already arrived. There'd be no chance to react, no time to hide, just a flash, and then nothing. Luckily, most gamma-ray bursts happen far away in distant galaxies. But what if one were aimed at us from a nearby supernova? Scientists say it's rare, but not impossible. And considering how little control we have over cosmic disasters, that's more than enough to send chills down your spine. Dark matter. Alright, let's talk about something truly creepy. Dark matter. It's everywhere, surrounding us, lurking in the universe, yet we can't see it, touch it, or even detect it directly. It's like the ghost of the cosmos, silently shaping entire galaxies while remaining completely invisible. And here's the kicker, there's 5 times more dark matter than normal matter. That means everything we can see, stars, planets, galaxies, only makes up a tiny fraction of the universe. The rest? An invisible force we barely understand. But if we can't see dark matter, how do we know it exists? Because galaxies behave weirdly. The way they spin defies the laws of physics, unless there's some unseen mass holding them together. It's like watching a Ferris wheel spin way too fast without flying apart. Something has to be keeping it intact. That something, dark matter. Now here's where it gets terrifying. Dark matter could be right here, right now, passing through us like a ghost. Scientists believe trillions of tiny dark matter particles may be zipping through your body every second without you even noticing. It's there, we just don't know what it is, where it came from, or what it might be capable of. The universe is mostly made of something invisible, something we don't understand, and if that doesn't send chills down your spine, I don't know what will. The Great Attractor. Imagine waking up one day and realizing that our entire galaxy, the Milky Way, is speeding towards something massive, something unseen, something so powerful that even light itself can't escape its grasp. Sounds like the plot of a sci-fi horror movie, right? Well, it's real, and scientists call it the Great Attractor. Right now, our galaxy, and millions of others, are hurtling through space at 1.3 million miles per hour toward a mysterious region of the universe. But here's the terrifying part. We don't even know what it is. This thing is so massive that it's warping space itself, pulling entire galactic clusters toward it like some cosmic magnet. So what is the Great Attractor? A supermassive black hole? A galaxy-eating void? Something we haven't even discovered yet? Scientists have no definitive answer. The worst part? We can't even see it. It's hidden behind the dense dust and stars of the Milky Way, locked away in a region ominously called the Zone of Avoidance, because even our best telescopes struggle to peer through. The Great Attractor is out there, waiting, pulling us closer with every passing second. And while it won't consume us in our lifetime, one thing's for sure, something gigantic and powerful is lurking in the dark, and we have no idea what it wants. Zombie stars. Just when you think a star's dead and gone, it comes back. Not as the bright, life-giving giant it once was, but as something far more terrifying. These are zombie stars, cosmic corpses that refuse to stay dead. Sounds like a horror movie? Well, space has its own version of the undead, and it's just as creepy. Here's how it happens. A white dwarf, what's left of a dying star, should just fade away into darkness. But sometimes it refuses to go quietly. Instead, it feeds. If there's another star nearby, this dead star starts pulling matter from its companion, growing in mass until, boom, it explodes in a violent supernova, only to leave behind another undead remnant. This cycle of destruction and rebirth keeps happening, making these stars the ultimate cosmic survivors. And if that wasn't eerie enough, there's a special kind of zombie star called a magnetar. This thing has a magnetic field a quadrillion times stronger than Earth's, capable of tearing apart atoms and frying electronics from hundreds of light years away. If one of these ever went off near our solar system, it could literally erase everything in an instant. So yeah, the next time you look up at the stars, just remember, some of them shouldn't even be alive. But they are, and they're still hungry. Rogue planets. Imagine a planet, a cold, lifeless, wandering world drifting alone through the darkness of space. No sun to warm it, no orbit to keep it anchored, no light to illuminate its surface. Just an endless journey through the void. These are rogue planets, cosmic orphans that have been violently ejected from their home star systems, doomed to wander the galaxy forever. Scientists estimate there could be billions of these rogue planets floating unseen in the Milky Way. Some are gas giants, massive and storm-ridden like Jupiter, while others are rocky, Earth-like worlds, frozen solid in the eternal night. But here's the terrifying part. Some of them could be passing right through our solar system and we might never even know. Since they don't emit light, they're nearly impossible to detect unless they block out a distant star as they move. Now think about this. What if one of these rogue planets was headed toward us? Even a near miss could disrupt Earth's orbit, throwing our planet into chaos. And if one actually collided, it would be game over. No warning, no escape. Just an unseen, drifting world appearing out of the darkness, sealing our fate before we even knew it was there. Cosmic void. Imagine floating through space, but instead of stars, planets, or galaxies surrounding you, there's nothing. No light, no warmth. Just an endless, infinite darkness, stretching in every direction. Welcome to the cosmic voids, the loneliest and most terrifying places in the universe. These voids are massive. We're talking hundreds of millions of light years wide, completely devoid of galaxies, matter, or even dark matter. One of the largest, the Butte's void, is so empty that if our galaxy were inside it, we wouldn't have discovered another galaxy until the year 3000. Just try to wrap your head around that level of isolation. But here's the real nightmare fuel. Why do these voids exist? Scientists don't fully understand how such enormous regions ended up with almost nothing in them. Some theories suggest they're just extreme examples of how the universe formed, but others? Some believe they could be leftover scars from something even bigger, something that may have altered the structure of space itself. And if you think falling into a black hole is scary, imagine drifting into one of these cosmic voids. No gravity to pull you anywhere, no planets to land on, just infinite nothingness, forever. That's true horror, not death, but endless existence in the absolute absence of everything. Andromeda. Right now, at this very moment, a monster is heading straight for us. A cosmic titan, home to 1 trillion stars, moving at 250,000 miles per hour, locked in a collision course with our own Milky Way. That monster? The Andromeda Galaxy. It's the biggest, closest, and deadliest threat to our galaxy. And there's absolutely nothing we can do to stop it. In about 4.5 billion years, Andromeda will smash into the Milky Way in an apocalyptic merger that will completely reshape the night sky. The sheer gravitational chaos will rip apart solar systems, throw planets into deep space, and ignite a massive wave of new star formation, but at a cost. Some stars, including possibly our Sun, could be flung into the abyss, left to drift endlessly between galaxies. And here's the eerie part. This isn't speculation, this is guaranteed to happen. Scientists have mapped Andromeda's trajectory with terrifying precision. Every second, it creeps closer, its spiral arms stretching toward us like a predator about to strike. But don't worry, you won't be around to see it. By the time Andromeda arrives, Earth itself might already be uninhabitable. So, in the grand scheme of things, maybe the universe is doing us a favor, wiping the slate clean before the real chaos begins. And that's just a glimpse of the terrifying mysteries lurking in space. The universe is vast, unpredictable, and full of things we barely understand. But that's what makes it so fascinating, right? If you enjoyed this deep dive into the dark side of the cosmos, make sure to like, share, and subscribe to InnoVision Tech for more mind-blowing space and futuristic tech content. What's the scariest space phenomenon to you? Let me know in the comments. Until next time, stay curious.